Let me introduce our next talk. We have two speakers, it looks like, for this one. This is a high school research program for underrepresented minorities in physics. Is that right that we have two speakers, Ananya and Landry?
It's just going to be me, but
okay.
Yeah. Let me just share my screen really quickly. Okay. Okay, so yeah, my name is Ananya Sitaram, and I am a graduate student at the University of Maryland in the physics department. And I'm going to be talking about the Physics Research Opportunity for Promoting Equity in Learning, or PROPEL. This is a program that I and another graduate student, Landry Horenberry, started this past year. And it's basically, as the title of my talk suggests, it is a high school research program for underrepresented minorities in physics. So yeah, first I'm just going to talk a little bit about the background and motivation for starting this program. So as you guys probably already know, there's widespread acknowledgement that there is a lack of diversity and representation in physics for certain groups, namely Black students, Hispanic or Latino students, Native American students, and also women. So for example, as you can see from the map I have on the slide, the Black population in the state of Maryland is close to 30%. But even though this is the case, in the past 5 years, the fraction of Black undergraduate students in the UMD physics department has not exceeded 5%. So this is really far from demographically representative as compared to the national average of 14.2%, but like even worse for the state population. So people often talk about the leaky pipeline issue, which basically refers to the process of losing a lot of underrepresented minority students as they move through, who are interested in physics and STEM as they move through their academic career. So since the University of Maryland is an R1 research institution with a large physics department, and also because of the demographics of the surrounding areas, it's in kind of a unique position to try to address these issues and improve representation in physics in our department, at least. So yeah, we decided to create PROPEL just to try to address the leaky pipeline issue by getting more underrepresented minority students involved in physics research earlier on in their education and kind of show them what they can do with physics outside the classroom and show them that they're capable of doing these things. So the program basically provides an 8-week research internship experience to high school students who are interested in physics or other STEM fields, but it is hosted by the physics department. And during the program, the students learn basic physics concepts and also introductory Python programming while also working on their research project. And this year, the program culminated in a 10-minute oral presentation about the students' work. And we held the program completely remotely this year, although we did end up having one in-person meetup where the students came to campus and we gave them some tours of a bunch of labs on campus. So that was nice. So the way that we recruited students for the program was by advertising it at the January 2021 installment of the Conference for Undergraduate Underrepresented Minorities in Physics, or CU2MIP. And this is a conference that's hosted by UMD and NIST. And so this conference is usually just for undergrads, but in 2021, there was actually a high school component to it. So we were able to go to that and talk to a bunch of high school students about the program and advertise it. And that is how we ended up getting the 3 students that participated in our pilot version of the program. So of the 3 students, 2 of them were women, and we ended up having 1 Black or African American student, 1 Hispanic or Latino student, and 1 Asian student. So the demographics were pretty good. And we recruited mentors for the program by just sending out a short application form to the entire department. all of our mentors ended up being graduate students rather than faculty, and 2 of them were myself and Landry, but I think this ended up being okay because as graduate students, we're able to spend a lot more time kind of like mentoring the students and really like coaching them through their project. So yeah, that ended up being okay. So as far as the program curriculum is concerned, we ended up having like 3 or 4 events per week during the 8 weeks of the summer, in addition to them working on their research project throughout. So we had a bunch of lectures and workshops on various topics such as Python programming, and then we also had some on general physics concepts. We had one on electricity and magnetism, one on waves, and we had another on classical mechanics and kinematics. And we kind of tried to like front load those lectures about like the Python programming and basic physics so that they would have those skills and be able to apply them to their project. And kind of towards the end, we had other talks about scientific writing and communication and how to present their research. So that came in handy when they had to put together their presentation towards the end. We also had a different speaker every week, usually a UMD faculty member, to talk about their research so that the students could kind of get an idea of what the different types of physics research are and all the different subfields that there are to study. And another thing I wanted to mention was that we had a few different joint events with a different program called Toolkit for Success, which was also just started this year in the UMD physics department. And there is going to be another talk about that later today at 2 p.m. So you guys will be able to hear about that. So yeah, now I'm going to quickly just talk about the 3 different projects that we had our students work on, just to kind of give an idea of what kind of project could be successful for a high school student to work on for 8 weeks during the summer. And they all kind of had different levels of preparation when it comes to physics and math and programming. So the first project we had was actually a project that I and another graduate student in my lab mentored a student on. So this was on imaging and analysis of a magneto-optical trap. So I work in a cold atom laboratory, and so we use lasers to cool atoms down to very low temperatures. And so basically we take images of the atomic cloud, and then we have to basically extract data from those images. And we had our Propel student write some code in Python to do the analysis of the images and extract things like the optical depth of the atomic cloud, the number of atoms, and the width and the temperature. And these are all like really important things that we use in our lab every day. So she was able to learn a lot about, you know, the physics behind our experiment and also really like contribute in a meaningful way. So yeah, and this was a completely remote project. This student did have a little bit of background in Python programming, but we still had to teach her a lot in terms of, you know, fitting models to the images and stuff like that. So it was a good fit. Our second project was about 3 different kinds of random walks. So this student analyzed and compared and contrasted 3 different kinds of random walks using Python and specifically Jupyter notebooks. So this is like the concept of a random walk is something I had never heard of until my statistical mechanics class in college. So I think it was really cool that this student was able to kind of learn about it, even though she'd only taken 1 basic physics class before in high school. And her mentor was able to kind of explain the concept to her using more concrete examples like the flight path of a cicada, for example, or the journey of photons in the sun. And this was also a completely remote project. And yeah, I have here like a screenshot from one of her slides from her final presentation. So yeah, the last project was actually mentored by Landry, and this project actually had an in-person component, as you can see from the pictures of the experimental apparatus. So this is on the effects of turbulence on salt water's conductivity. And yeah, basically this student kind of expressed interest in fluid dynamics. So Landry was able to put together this project for him. So that was really cool. And they did end up finding some evidence of a positive correlation between turbulence and conductivity. And one thing that's really awesome is that this project is still ongoing, and the student actually plans to keep coming in and working on it during the school year whenever he has time. So yeah, that's really good. Okay, so obviously we had to run the program completely remotely this year because of COVID, but that did come with some benefits. There's like a lower cost associated with running a program remotely, and also the logistics were way less complicated, and it's just way easier to kind of start a program in a remote form, I guess, because there's just less to figure out. But yeah, and then we were also able to make use of the Physics and Astronomy Anti-Racism Coalition summer Python seminars. So this is a different organization that spans across many universities, and they were putting on Python seminars aimed at beginners throughout the summer. So we were able to send our students to those as well, and they were able to interact with kind of a larger community of students. In the future, I think we see this program kind of taking a hybrid form, and we could still do remote workshops and lectures over Zoom, but you know, some of the students could come into campus to the lab to do their projects, so that all the projects don't have to be remote, and we could still have lab tours and university visits in person. The other thing is that with a hybrid approach, the program would have a lower cost, and that would allow it to scale better for a given amount of funding. So the challenges that we faced in trying to start the program was, one of them was that there was limited faculty support, and I'm not saying that to make it sound like it was really bad, but basically I think that it's hard to start anything, and as I said, like all of our mentors ended up being graduate students, and in the future we would like, you know, more involvement in the mentoring from faculty. But I think, you know, this was just because a lot of the faculty were kind of wary of, like, they didn't know what type of projects that a high school student could work on. So I think now that we have 3 successful projects, we can kind of show those as examples, and we'll have more success with getting them involved in future years. Another challenge was adapting to remote learning, which I'm sure all of you guys know. It's really hard to keep people engaged over Zoom and like explain difficult concepts. So yeah, I mean, that was a challenge, but we did our best. And then also kind of related, developing suitable projects for a high school student that would be remote. So like if the project is going to be completely remote, it essentially has to be like coding based, or, you know, simulation based, or just doing calculations. And so that's really tough with a high school student's background, but I think we did a decent job of like teaching them just enough so that they were able to do something while keeping it not too overwhelming. And then I think the way that we can kind of address these challenges is by starting as early as possible and trying to secure faculty, mentors, and such. So some future steps that we'll take for the program is trying to get increased involvement from the faculty, as I said, and maybe trying to have them more involved in formulating the different projects for the students, while still probably keeping the day-to-day mentors for the students, graduate students, just because I think that worked out really well. We are working on trying to get funding for the program so we can provide compensation for the mentors and other people who help out, as well as provide stipends for the high school students who participate in the program. And the last thing I wanted to mention was that with the Propel program and the other program, Toolkit for Success, that I mentioned earlier, there could be kind of a possible pipeline between those programs where high school students who participate in Propel, if they then end up applying to UMD for college and end up going, they could then participate in Toolkit for Success, which is for incoming freshman physics majors. Yeah, and this is a picture from our on-campus visit this summer. So yeah, I just wanted to thank you guys for listening, and I wanted to thank Landry for being like the co-creator and co-organizer of the program with me. Definitely couldn't have done it without him. And I also wanted to thank Peter Elgi and Narain Manjunath, who were the other mentors for the program. And I wanted to thank Donna Hammer and Angel Torres, who are the organizers for the Toolkit for Success program, for all of their advice and help throughout the process. And yeah, if you have any questions about the program or want more information, don't hesitate to reach out to either me or Landry. I have our emails on the screen. And if you know any high school students who are interested in applying for the program for summer 2022, there is a link to the application as well. So thank you.
Thank you. That's fantastic. I think you would be hard pressed to find a college or university who did not want to address and maybe model something like this. So I'm really glad to see a university like the University of Maryland taking.
Yeah, it would be really cool to see this happen at
we have several
universities as well.
Questions and comments in the chat.
Yeah, I'm trying to look through.
Do they need to be Maryland residents?
So I mean, I guess it's kind of aimed, it was supposed to be aimed at local students, but like, so I guess if they were going to be coming in person in the future, then, I mean, like, okay, the way I see it is like, we could have non-Maryland residents in the future if it ended up being like a larger program and we ended up getting like housing for students and stuff. But yeah, I mean, the way it was this year, I guess they could have lived anywhere because it was over Zoom anyway, but.
Maybe anywhere in the Chesapeake area.
Yeah, yeah.
I would love to see a long-term track of where they're coming from and then of where they go. That would be fantastic. I look forward to seeing what that looks like.
Yeah, and then someone was saying, do you think something like this is feasible for community college students? Yeah, I mean, I think it definitely could be. I mean, I think like they could even apply to the Propel program. I mean, we're pretty open to taking any students. Okay, if you need faculty mentor. Okay, sorry, I'm trying to like read through all the.
That's right. I don't see other questions right now, but I'm sure people may have follow-ups afterwards. Okay. And that's okay.
If I could, I mean, could I just ask one quick question? I mean, have you thought about exactly what is the sort of goals of what you want to accomplish with the project? I mean, are you hoping that this is going to help reduce the leaky pipeline? Or I'm just wondering whether you've tried to articulate exactly what the goals are that you want to come out of the program, so that you can then see whether or not it's successful in achieving those goals.
Yeah, I think that's exactly it. I think like we do want to try to like address the leaky pipeline issue and just, yeah, try to introduce these students to physics research earlier on so that they're not like discouraged from physics and STEM in general. Yeah, like I guess we still kind of have to think about how we're going to like measure how successful the program was. We did have like I guess like a post-program survey, but yeah, we still need to think about that, I guess, a little more carefully.
Yeah, to do pipeline stuff, you actually have to follow them.
You have to like track the students,
like
yeah,
over years or something, and that can get expensive and complicated, but it might be worthwhile to do so.
Yeah, definitely.
Wonderful. Thank you very much.